We are now on our last lesson, which is the relative velocity. Relative velocity, when a body P, a body denoted by P, moves relative to another body denoted by B, and B moves to relative to A is also another body, so we have three bodies here. So if we will read the next symbol, that would be velocity of P relative to B, velocity of P relative to A, and velocity of B relative to A. So our formula here would be the velocity of P relative to A is equal to the velocity of P relative to B plus the velocity of B relative to A, where their units are meter per second. So since we're talking about relative velocity, we have our problem here. The compass of an airplane indicates that it is headed due to north, and its airspeed indicates shows that it is moving through the air at 240 km per hour. If there is a 100 km wind from west to east, what's the velocity of the airplane relative to the Earth? So we need first to write our given. The velocity of the plane relative to the air is equal to 240 km per hour due to north. Next, the velocity of air relative to Earth is 100 km per hour due to east. So how will we solve that? So solution, that would be velocity of plane relative to Earth, which is the unknown, is equal to the velocity of the plane relative to air plus the velocity of air relative to Earth. In order to solve that, we can use the formula V is equal to the square root of Vx squared plus Vy squared. Substitution. So the velocity of the plane relative to the Earth is equal to the square root of 240 km per hour squared plus 100 km per hour squared. So in calculator, the velocity of plane relative to the Earth would be 260 km per hour. So if you also want to solve for the position, you can use the arctan. Theta is equal to the arctan multiplied by Vy over Vx. So arctan 100 km per hour over 240 km per hour. So theta is equal to 23 degrees east of north. That will be our final answer.